Hello all, welcome to the third session conducted by Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session conducted by Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session conducted by Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session conducted by Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session
Let's go to the
conducted by
presentation.
Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session
Let's go to the
conducted by
presentation.
Voltage Voice. We'll be starting the class now. Hello all, welcome to the third session.
Now this session.
various objects like the truck over here, antenna over here, mobile signals over here, and all interact with the satellite. Objects like that. That's also one method of communication only. This is just an example of two objects communicating with each other. Okay. So how to implement this in hardware? There is something called a source. Like the source is the one which sends the information, and then there is something called as transducer. This might be a new term for you. Transducer is any device which converts one form of energy to other. So here, let this input message be of any form. This input message is converted to electrical signals by this input transducer. Is that clear? Is that clear? Like transducer is the device which converts any one form of energy to another. Yes, fine. And then there's something called transmitter. This might be a familiar term. Transmitter is the device which transmits this electrical signal to the channel. Channel is the medium of communication. So this transmitter sends this electrical signal to this channel, where this signal sent over here is manipulated by even noise. Noise is like noise is also a type of signal only, but the thing is that noise is in unwanted signals or inappropriate signals for the particular communication process. So now in this channel, noise influences the electrical signal, and then this overall total electrical signal is received by the receiver. And now that electrical signal is sent to output transducer. Output transducer converts electrical signal to the form of signal we need. So we might not always need an electrical signal. Instead, we might, if this is a buzzer kind of a thing, then we might need sound energy over here. If this is a LED kind, then we'll be needing light. So that will be the output message sent by the transducer, and then that will reach the destination, and it'll make sure that the whole process is complete. Now, this is the way we implement digital communications in hardware. Now, let's go to the next thing, wireless communication protocols. So here you can see there are no wires. That's all. Yes. So there are types of wireless communication protocols. I can say they can be categorized into short range, and then cellular communication, and then LPWAN. LPWAN is nothing but low powered wide area network. Okay. So what is wide area network? Wide area network is a communication method which helps systems with systems in 1 kilometer radius to communicate with each other. Like, though the distance between objects can be 1 kilometer also, we can use this wide area network to communicate with make the two systems communicate. Now these are like very basic categories of wireless communication protocols. Here you can see NFC, Zigbee, Bluetooth, and Wi-Fi. So these all comes under short range wireless communication protocols. Like Zigbee is a protocol which balances Bluetooth and Wi-Fi. So here actually Bluetooth has very less range. How I can say, like number of devices to which a Bluetooth system can be connected is very less. And if you take this Wi-Fi, actually Wi-Fi is considerably high, but Wi-Fi consumes too much power. Now this Zigbee balances these two. And you can see here this NFC. This NFC is actually a very short range communication protocol, but this is majorly used in e-wallet systems. And cellular communications, you might be familiar with this. This is actually the day-to-day communication protocols we use: 2G, 3G, 4G, 5G, and all. Currently, we are using majorly 4G and 5G only. 2G and 3G are out of trend, I can say. And then applications of this is your cellular communication. That goes as the major application. And then is LP WAN. LP WAN's applications goes like you can apply LP WAN protocols in smart city projects. So like when you want to have sensors across the road and detect how many vehicles are going and adjusting the street lights according to that, then probably you might need an LP WAN for communication. So this is uh, just an overview of wireless communication protocols. Is it clear? Yes, I guess it's clear. And even participants have been increased. Yes, nice. The next thing, wired communication protocols. Wired communication protocols are UART, SPI, and then I2C. So what is UART? Like full form of UART is Universal Asynchronous Receiver and Transmitter. SPI is Serial Peripheral Interface. I2C is Inter-Integrated Circuit. So these are just abbreviations of these three short forms, like full forms of these three abbreviations. We'll get to know about these in the coming slides. And here actually you can see this new term called asynchronous. So to understand more about this asynchronous, you have to get to know about importance of clock in communication. So what is a clock signal in communication? Clock signal is nothing but particular type of signal that oscillates between high and a low state. So here you can see this particular thing is the high state, this is the low state. So low state is basically the 0 volt or ground, I can say, like not exactly ground, it is the 0 volt state. And high is the maximum voltage state you can have. And clock actually makes sure that the signal oscillates between high and low at a particular frequency continuously. And this frequency is the one which manipulates the rate of data transfer in communications. So rate of data transfer in the sense, if two devices are communicating, one device will be sending the information and another device will be receiving the information, right? So now the device which sends the information will send it in a particular frequency, and that same frequency must be set up in the uh, receiving device as well. So both this frequency or this speed is called data transfer, and clock is the one which manipulates this data transfer. Is that clear? Is that clear? Yes. Okay. So after knowing to the getting to know about this clock, let's get to know about what are asynchronous communication protocols. So asynchronous communication protocols are protocols where these clocks are not linked to each other. So I said two devices, right? Here. So assume these are the two devices which communication is happening. One is the transmitter and another is the receiver. So clock of the transmitter is connected to clock 1. Receiver, a clock of the receiver is connected to clock 2. So by this, I indicate that both are connected to individual clocks. But still the communication happens because these two clocks have been given the same frequency. That are those are asynchronous communication protocols. So yes, UART is an asynchronous communication protocol. Like imagine there are two devices having individual clocks and their clocks are not connected. Instead, they are given the same frequency. So why the same frequency? see this video, like, okay. If you see here, data is being transferred from transmitter to receiver, right? So if both doesn't have same frequency, this will send, imagine transmitter is having higher frequency. So that will send this data faster, and receiver, if it is set in a low frequency, then that cannot receive data in that speed, like the speed of data being sent. In this cannot receive data in that speed, and hence in between data will be missed. Hence, we must set the same frequency in both transmitter and receiver. But the only thing is that we are not connecting clocks. Instead, we are giving different clocks of same frequency. Okay, is that clear? Is that clear? Is that clear? Yes, yes, no, something like that. Yes, finally one yes. Okay. So, as I said, like that, whatever I said, this, that, this. The next thing is that this is serial communication. So, the protocol UART is for serial communication. So, what is serial communication? Again, this video helps. Here you can see that data is being transferred bit by bit. Like, if imagine that 0 is now going into receiver, next 1 goes into this receiver, and again 0 goes, and something like that. Wait, see that each ones and zeros are called bits. So now, so whatever ones and zeros being sent are called bits. So you can see here, the whole data stream is sent bit by bit to the receiver. Now this 1 is going in, right? Then this 0 goes in, and again this 1 goes in, and the next 0 goes in. So each bit is transferred at 1 clock frequency. So whenever 1 clock pulse is completed, 1 clock pulse consists of 1 high and 1 low. So whenever 1 high and 1 low gets completed, 1 data bit is transferred to the receiver. So this is the way serial communication occurs. So this is basically called serial communication. And yeah, is it clear? What is serial communication? Some other responses. So till now, whatever has been taken is clear. Great to hear this. Yes. And this is what I said. Data is transferred bit by bit for every clock pulse in individual device. Like in individual devices, there will be clock pulses, right? So when as these both are given same frequency, both will have clock pulse at the same time. And when one clock pulse is completed in both the devices, the 1 bit of data is transferred from transmitter to receiver. That is the process. And as clock is not linked for devices, both are given same frequency. Our two devices are linked with same baud rate. Baud rate is nothing but the data transfer. We said it in first class as well. We said it in the second class as well. Baud rate is nothing but the data transfer. And both the clocks, rate of data transfer, and both the clocks are given with same frequency. And here that frequency is nothing but the rate of data transfer, and hence it can be called as baud rate. Yes. So let me start about the features of this protocol. This protocol is actually two-wire. Like, ignore this ground wire. Okay, ground wire is common for all communication protocols. So ignore this ground wire. Ignoring this ground wire, there are only two wires. So if you say there are two devices communicating, device 1 and device 2, two wires are connected between device 1 and device 2. One to send data from device 1 to device 2. Another is to send data from device 2 to device 1. So here device 1 has two pins, RX pin, TX pin. Device 2 also has two pins, RX pin and TX pin. TX pin is the pin which transmits the data. RX pin is the pin which receives the data. So device 1 of TX is connected to device 2 of RX. Device 2 TX is connected to device 1's RX. Because if I want to transmit the data from device 1, I have to start the wire from TX. And if data must be sent from device 1, it must be received by device 2. And hence, it is connected to RX pin of device 2. Similarly, if device 2 must send the data, then that must be connected to TX and it must be connected to the RX pin of device 1. Is this clear? Is this clear? Any doubts? Okay, can you repeat? I will. There are two pins here, right? TX pin, RX pin. TX pin is to transmit the data, RX pin is to receive the data. For one particular device, RX pin receives the data, TX pin transmits the data. And hence, if I want the data to be transmitted from device 1, that must be connected to the RX pin of device 2. Because device 2 must receive the data. It must receive what data? It must receive the transmitted data from device 1. Hence, TX of device 1 is connected to RX of device 2. Similarly, TX of device 2 must be connected to RX of device 1. Is this clear? Is this clear? Like the one who. Oh, okay. Nice. Okay, let me continue. Once after this, so you have got to know about what is an asynchronous communication protocol and how it can be implemented in RX. I mean, UART. Here you can see that clocks are not linked to each other. I haven't shown the clock connection over here, but still clocks are not linked to each other here. And now let's go to the synchronous communication protocol. Yes. GitHub to like see here, like these two are protocols, I2C, SPI, SATA, LIN bus, linear bus, that is in Bluetooth and all, depend on this master slave terminology only. So this is one basic name. Let's get started with SPI protocol, which is a synchronous protocol. So what is a synchronous protocol? Synchronous protocol or synchronous communication occurs between two devices when clock of both the devices are connected. So in asynchronous protocol, we saw that both the clock pins are connected to individual clocks, right? Here, clock pins of both the devices are connected and that both are connected to one common serial clock. Okay. So here, two devices, if there are two devices, they'll have clock pins. Both the clock pins will be connected and these clock pins will be given to a serial clock. What is a serial clock in a sense? Serial clock is it's like a normal clock. It's just a terminology given. Yes. You might have to like as I mentioned before, SPA protocol is actually master slave protocol, master slave based protocol, I should say, and it involves four wires. In UART, we saw only two wires are involved. Here you can see that there are four wires involved. And though it is a master slave protocol, it is not necessarily that there must be only one master in the whole system. There can be even multiple masters, but in most cases of implementation, we will get to know that SPI protocol has only one master and rest all are slaves. So what is a master? What is a slave? Master is the whole device which controls the communication and controls the data transfer as well as the clock. So if I say controlling the communication, it controls two things. One is the data transfer, another is the clock. So see, data transfer need not be necessarily from master to slave itself. It can be even from slave to master. But even though it is from slave to master, what is the thing? The commands are being given by master only. Like when the slave has to give the data to the master, master only ships it. That is why it is master. Is that clear? Like the whole control of data transfer must be in uh, whole control of data transfer belongs to the master only. It doesn't belong to the slave. But data transfer can occur from slave to master as well. Is this point clear? Is asynchronous protocol P to P in the sense, are you saying point to point? Okay, fine, no responses. Is this clear? Like whatever I said now. Show some responses, guys. Come on. Yes, fine. Finally, one response. As you said, as it is very small, I put it in presentation. We might, that's it, to say in this way. And basic features of SPI protocol is that it is short ranged, high speed, uh, like it is high speed in the sense speed is higher than the UART protocol which you saw or I2C protocol which you're gonna see. Okay. And data transfer which is transferred will be in form of both 8-bit and 16-bit. I said what is a bit, right? A bit is one, either a 0 or 1. Like in a whole data is composed of bits, and each bit can be either 1 or 0. And SPA protocol allows data transfer which is of the form of 8-bit or 16-bit. So it can have either 8 digits where each digit can be 1 or 0, or it can have 16 digits where each digit can have 1 or 0. That is the meaning of this sentence. So data will be transferred only in one direction in wire connections. So you'll get when you get to see the wire connections, you'll understand more on this point. And see, data can be transferred from master to slave as well as slave to master. But in the last slide we mentioned data is like wire connections can have only one side of data transfer, right? From that, you can now infer that there will be two wire connections, one from master to slave, another from slave to master. And as these are having two different wires only, you can see that both can happen at the same time as well. Like the data being transferred from master to slave as well as from slave to master can happen at the same time. Hence, that is called full duplex method of communication. So, full duplex method is nothing but a terminology, and that means that communication can happen in both the directions simultaneously. Okay, and wiring required for a here you will see that there are four wires, and all wires are unidirectional. See, this wire goes from master to slave, slave to master, master to slave, master to slave. All wires are unidirectional. And there are 4 pins: MOSI, MISO, SCLK, and SS/CS. Now, MOSI and MISO, you can infer from the name: master out, slave in, master in, slave out. So, what is master out, slave in? Data goes out from the master and it reaches the slave. And what is master in, slave out? Data goes out from slave and it goes into the master. That is MISO, MOSI. I'll repeat once again. MOSI is nothing but master out, slave in. MISO is nothing but master in, slave out. MISO happens from slave to master. Data transfer happens from slave to master. MOSI happens from master to slave. SCLK is nothing but serial clock. And SSRCS is the chip select or slave select pin. So serial clock, you might know that, as I said before, it's a synchronous protocol. Clocks are connected to each other. Both master and slave devices, assuming they have inbuilt clocks, both are connected to each other. Okay. And slave select or chip select pin, this is the most important pin. So as I said before, SPI protocol enables one master and multiple slaves as well. Like this not necessarily between only two devices. This can have multiple devices, but which slave must get the data at a particular time, that is chosen by this slave select pin. So the slave select pin gets activated whenever I want a particular slave to be selected. That particular slave select line alone gets activated. Rest all are in the same deactivated state, but I need to activate one slave, right? That slave's covers SS connection alone gets activated at that particular time. Is that clear? Any doubts? Any doubts till now? Responses from all directions, guys. Fine. Yes, thank you. Okay. Yes. Next, let's go to I2C. So, what is I2C? I2C is nothing but inter-integrated circuit. Even this is a synchronous communication protocol only used for serial communication. And like in previous slides itself, I told what is synchronous communication protocol and what is serial communication. Slower, like here you can see that speed of I2C protocol is 400 kbps. I2C communication systems is only 400 kbps. But in SPI protocol, we saw 10 Mbps. So SPI and I2C both are synchronous, but data transfer here is slower. You'll get to know that why it is slower. So this is also called as two-wire interface because apart from the ground wire, there is only two-wire connections. Okay. And what are those two-wire connections? Serial data and serial clock, SDA and SCL. Okay, these are the two wires. Though there are only two wires, it can have up to 128 devices in communication channel. See, the only excuse me, sorry. So like, though there are only two wires, it can have up to 128 devices in communication channel. But in SPI protocol, I mentioned four wires, right? So you can just tell me now. Imagine there are multiple slaves. Then see, you have asked, right? Why do we use I2C? Then, as in, what advantage does it have over SPI? So the advantage which I2C gives is this lesser number of wires. So if you take, yeah, so if you take SPI, for each slave, I must have separate slave select wire. or else all slaves will get selected at a particular time itself, right? Each slave must have separate wire. But here, I need just two wires. One is SDA and another is SCL. With those two wires itself, I can do all communication. Like I can connect how much ever slaves I want. Is it clear? Satvik. Is that clear? Yes, nice. Nice that you're asking doubts. Okay. So again, you might think 128 odd like it's not a round of number, right? That is because in I2C, what gets transferred via data line SDA first is that it is the address of the slave. So in I2C, you are addressing each and every slave, and this address is nothing but a 7-bit address. So what is a 7-bit address? I said like what is 7-bit in a sense? Can have 7 digits, and each digit can be a 1 or a 0. That is 7-bit address. So now you can do those permutation combination stuff and all, and see that each bit has two possibilities, either 1 or 0, and hence a 7-bit address has two person possibilities. As each bit can be either 1 or 0. Each place there are two options, and for 7 bits there are two person options. Two person is nothing but 128. Hence only we say that 128 devices can be attached. Okay. And multi-master, as I said before, this is also a multi-master system. And that multi-master systems over here are more common than what you see in SPI. You'll get to know that why it is. So here, basic thing is that both master and slave are connected via SDA and SCL. So if I want to attach multiple slaves, all I need to do is I must stretch wires from SDA and SCL and consecutively connect all these slaves to that same wires itself. Okay. And whenever no whenever no communication occurs, both SDA and SCL wires are high. Like here you can see these two wires, right? Both these wires will be in high whenever no communication occurs. High means both will be in the one state or high as you can understand. Okay, is that clear? One sec, guys. I'll come back. Yes, I'm back. Yes. So I2C protocol has this phenomenon called clock switching. So what is that? We'll get to see. Slave is actually doing a task after receiving the command from master. As I said before, though the task can be sending data to the master as well, but master must command the slave when it must send data and when it must do tasks. Okay. So imagine this a slave is like very complicated, has a very complicated structure. Then for each task it will take time. So, but what if the commands which master sent are very fast? In that case, this clock switching helps. So here you can see this pic, like master and slave are literally fighting for clock. So master wants to move the clock in the frequency which is programmed, but slave actually wants the data rate or clock rate to be slower. Okay. Master wants the data flow rate as per program, but slave wanted it to be slower, and hence what slave does is that the slave pulls down the SCL line to low. As I said before, imagine clock's oscillations are very fast, and after a time, the clock will reach high, and imagine the clock stays in high for a long time. Then the communication will get inactive, right? Hence, slave can take charge on the SCL line, and it can pull down the SCL line to low for some particular time, and thus this process slows down the clock rate, and hence it can receive the commands in the speed it wants, and hence it can execute the task perfectly. I will repeat once again. Whenever task done by slave takes time, it can force the SCL line to remain in low state and not go to high permanently, which is nothing but the inactive state, and thus slow down the clock rate until the task is done by the slave, after which clock will return to normal rate. And then now we can see that slave actually takes control over SCL part of the communication process. And this is how I2C becomes multi-master protocol. Is that clear? Yes, I need more responses. I received one clear. Maybe I can repeat it once more. SCL protocol, like not I2C protocol, has a phenomenon called clock switching. Okay. I2C protocol has a phenomenon called clock switching. You know what the clock switching does? Whenever task done by slave takes time, it forces the SCL line to remain low, and this whenever this force is applied, clock rate is slowed down, and hence slave can does the task in the time it wants, and after doing the task, clock rate will return to a normal rate. Okay, and this is how I2C protocol or I2C communication systems turn to a multi-master connections. And then finally, after a lot of content, we are into this seeing this Arduino board again. Here you can see, like first class, we mentioned some pinouts, and now we can see some add-ons to pinouts. So here, I2C, we mentioned right, two pins will be there in Arduino which are unlabeled. These two are nothing but the I2C pins, which is SCL and SDA. And these pins 10, 11, 12, 13 are nothing but SPI pins in Arduino board. Okay. So after getting to know about I2C, we'll get to know about how to make Arduinos communicate. So these are two pictures, right? So any guess on what we'll be using? This stick is like a Pictionary thing only. Try to combine this and get to know like what we'll be using to make two Arduinos communicate. Any responses? Or yeah, library fine. What library? Try to get it from the first picture. Yeah, exactly. So this is one thing I tried. Wire library. That that is one thing we'll be using to make two Arduinos communicate. So before getting to know about this library, let's see this particular thing. So when you make two Arduinos communicate, you have to make sure that one Arduino is the master and another Arduino is coded to be the slave. So that depends on your programming only. So if you put two Arduinos in your workspace, you can code one Arduino to be the master and another Arduino to be the slave. But as I said before, slave can take control over the clock signals, and then even it tries to be the master at times. But still, it is a slave only. It has that confidence that it can be a master. Okay, so let's get started with the coding part. Maybe you might get excited after this. So anybody needs time to open their Tinkercad and set up this SPI? Why SPI? It works on I2C, to communicate. As I showed you here, here you can see there are two I2C pins, right? These two pins are the pins we'll be using to make two Arduinos communicate. Of course, you can use A4 and A5, but these two pins are programmed to be SCL and SDA in Tinkercad, and hence we'll be using this. The two unlabeled pins above this AREF pin. Okay, we'll be working on I2C protocol only. Okay, can ESP32 can ESP32 be used? It's connected using Bluetooth or Wi-Fi. Arduino uses two wires to be connected. Yeah, exactly. Arduino can even ESP32 can be connected using wires, but Arduino can not be connected by Bluetooth. It needs two wires to be connected. Okay, so let's get started with coding part. Okay, one more. Okay, fine. No, it's good. Mm. Actually, using I2C, we can make even this complicated circuit. Okay, it's fine. I will link this. I link this circuit in the presentation later. You can get to see this circuit and then really think about how complicated things also you can explore in I2C communication in Arduino alone. So as I said before, for I2C communication, you need two Arduinos. Like for our case, at least, we need two Arduinos. Yes, these are the two Arduino boards which we are going to use. And as I said before, there are only two wires connected from one SCL. And then connect to SDS. Yes. And then, but you have to also connect the ground of two Arduinos to make sure that communication happens between two Arduinos well. And then, as I said before, whenever you are using ground wires, change the color to black. Is this clear till now? What I'm doing is I'm taking two Arduinos and connecting the SCLs of two Arduinos and SDAs of two Arduinos. Is this clear till now? Is this clear? And then you have to assume one board to be a master and another board to be a slave, right? So for now, assume this board is a master. Like the board to your left is master, is named as one. I'm going to rename this as master. So remember that one is master and two is slave. Okay. And now what I'm going to do is initially in first class we did a circuit, right? What circuit we did? The first circuit which I demonstrated is you're using a push button, and with that, whenever the push button is pressed, you're making to glow an LED. That is the first thing we did. Now we are going to do the same thing, but the thing is we are gonna put push button in one case, like in one Arduino, and LED to the other Arduino. Okay. So best way to use push button is by using a mm. So connecting this Arduino pin is perfectly well. So what are the basics again for a push button? One terminal must be connected to negative. Let me put this ground over here. Yes. Then let me put down this ground wire. Yes. And hence this ground is perfectly linked. Now I will link the VCC. Okay. So I am this ground and VCC part is fine now. Now I have to connect the output part. Yeah, I'll just revamp this wiring slightly. Yes. Till now the wiring is clear, right? Why we are using a resistor and a push button, all are clear. Is this clear? Whatever we used, whatever we did till now. Fine, we'll go ahead. Uh, Now we have see, we are connecting the push button to the master Arduino, and we have completed these connections. Now we'll go to the slave Arduino. What we'll be doing in the slave Arduino is LED, cathode. So cathode must be connected to ground, and any ground wire can be converted to black. And then I'll change the color. I'll put it in green. Okay, I need a resistor for LED. Okay, so now my connections are done. Like whole circuit connections is done. This is what have planned and I've done the connections. Is this clear? Yes. Now, now is the main thing. We have to get started with the coding. I've selected the master Arduino or Arduino number 1. Okay. I have to change this to text. Continue. I have to remove all these codes. Let me code it from start. And as I mentioned before, we are gonna use something called wire library, right? And hence we have to include that library. How we'll include that? This is the syntax. Hashtag include, and then angular brackets. We have to put the library name inside angular brackets and then put dot h. Now the library is included. Okay. Now let's go. Int button. I connected the button pin to pin number 5 here. Hence I am naming int button is equal to button equal to 5. Then int x is equal to 0. I'm naming this as int x equal to 0 because I need some variable to receive the button state, right? Or whether the button is pressed or not, I need some variable to receive that particular state. Hence, I am giving that as x. And if it is pressed, then it will be 1. It will be not pressed, then it will be 0. Start the void setup. And then this the first wire function will be function from the wire library will be using wire.begin. So why I am using this is to start the or else to initiate use I'm searching for words. Trans- Data transfer. Transfer from master. So whenever we have to initiate the data transfer from the master, we have to give wire.begin. This is the first step we'll be following. The next one, okay. So one important thing I missed here is color. The next thing, after giving this, that is done. I have to give pin mode for that button set button pin. These are all the stuff which we saw in first class. And then again here new stuff will start to come. White loop. This is the first thing. Wire dot begin transmission. And in argument category. This is not necessarily one. One I am meaning is the address which I am giving to the slave. Okay. And this wire.begin transmission is the one thing which actually starts the transmission. Here it is just an initiation step. And this actually starts transmission of data to via that SDA line. Okay. X equal to digital read of button pin. Then after like this assigns a value to the X variable. Now what I have to do, I have to transfer that X variable to the slave Arduino. Hence I have to write that onto the SDA line. Hence I am giving this particular function wire dot write of. I am writing the variable X onto the SDA line. And once I have written that, I can end transmission. Is clear? Is this clear? What is one? One is actually the address which I am giving to the slave. It is not necessarily a one line. As I said before, I2C can use uh, 7 bits, right? Hence, I can give any address. Here I am giving 1. Maybe after running this program, we'll also give 10. We'll give and see 10 and all those stuff. We'll see what is the difference. There will be no difference if we change accordingly even in the slave as well. Is that clear? Okay. How about the others? Is it clear? Can you explain the code again? Fine. So int button is equal to 5. Here I am using fifth pin. Hence I am giving button equal to 5. And x equal to 0. That is the variable which I am going to input the digital read value of that button pin. So I'm giving initiating that here itself. I can also do this instead of this. It will be like this itself, like there is no issues. Instead, I can even give here int of x as well and remove this statement, but that doesn't matter. Next thing is that void setup wire dot begin. This is just to initiate the data transfer process from master, and then mean one is the address, and I have to begin transmission to that particular address. Okay, that is why we are using this begin transmission, and here actually mm, and then x equal to digital read button wire dot write of x. That is x equal to digital read of button is actually the real meaning why I initiated x here itself. And once we read the state of this pin, I have to transfer that to the slave Arduino so that LED glows or it doesn't glow, depends on the value of x. And hence I am writing x onto the SDA line, and after writing, I'm ending the transmission. Is that clear? Is that clear? Yes. And this is the code for master. Now let me go to the code for slave. Even in slave, I have to include the wire library. Okay. And I have to start coding. Here I have connected even the, see, it's not necessarily, I'm connected to 5 here and even 5 here. But that doesn't really make sense. Like that 5 is just random. I can connect it over here even to 7. Only thing is that I have to change that value of LED over here. That's it. Putting it here, and as I given that to 7, I'm changing that int of LED pin. I'm naming that 7th pin as LED, and int of y equal to 0. You'll see why I'm initiating another variable here. I can start the void setup. This one is actually how I will, like, one here is the address which I gave in begin transmission. So that same one or whichever address I gave there, I must give it over here. And then I have to set up the pin mode of that LED pin. And then I have to set up wire dot on receive command. This is one new command, and this is one thing that's slightly complex. Receive event. Now the receive event I have given here is just a uh, it's my own name. Like, name given by me. This can be anything. Okay. And after that, I'm closing this and I'm going to the void loop. And then what must happen in loop? Uh, just one second. If value of y is equal to like before defining loop, I define this void receive event function. So the receive event I gave there is actually the function which I want to define. Okay. And now that function is nothing but x is equal, sorry, not x. Here I have given y, right? And I'm actually transferring the data via this SGA line. What I'm transferring? The value of x. And here that is x. And here I'm naming the receiving value as y. And hence what I must do? As y is nothing but the receiving value, I have to give wire dot read of. Point here. This is what this receive event function for me must do. Receive event function is actually must do like whatever value I have to receive or whatever stuff I want to receive, I want to put that as a function and I want to give that a on receive of receive event. On receive argument. Okay. Argument of on receive function. Wait. Argument of on receive function must be a function itself, and that function must actually receive what value I want to receive from the SG array. Is that clear? If this point is clear, I think the loop part will be clear for you. Yes, fine. While loop what must this loop have? If y, the received value, is equal to 1, then I have to write digital write of LED pin to be high. If or else digital write of LED must be low. Now, is this clear? How to code separately? What is the use of a wire on receive? Okay, fine. So wire on receive is actually the function which makes sure that receiving what I have to set up in such a manner that receive event is nothing but the function which I want to use to receive the value which is there in the SDLA. Okay. Yeah, it is possible. It is possible. Digital write of LEDY is possible. Wire on receive is used to set up that receive event function in such a manner that it must receive the value from the SDLA. Simply giving extra wire x equal to wire of read may not always receive the value directly, and then like how to say, that may not work at all cases. And I have to give this even wire on receive just for an extra communication. Is that clear? Like yes, just yes, I'm back. So like as one pointed out, that was a very nice point. Like that receive event function is actually going inside on receive, right? And hence that mustn't be void. Like that mustn't how to say, that must return some value. This receive event function must give out a value. Hence I must mention that value over here. Let that value be some value. Like that is just to make sure that this receive events brackets must not be empty. And as this goes inside on receive, like see, on receive is a function. Now, receive event is a function inside on receive. Hence, whenever this on receive function acts, that will go to receive event and it must return some value, right? Hence, I'll put that value as that. This doesn't like there is no much significance, but to make the code run in a proper manner, I need this value inside receive events bracket. Okay, so if I start. You can see that whenever I'm pushing the push button, LED glows, and if I release, LED doesn't glow. And if I again push, it is glowing, and if I release, it is not glowing. So this inset point is somewhat more oriented over coding logics like void functions and non-void functions and all more than the electronics part. Okay, so you can just take this abstract and then uh, go on for your further applications of I2C communication. For basically this receive event function which you are setting up must return somewhere. Okay. Yeah, I'll show the code. There is no issue. Subhadeep, is that clear? You are the one who raised. Thank you for raising. Error invalid header file in the sense you might have done some error in your code part, like hmm? See, like int receive event makes that a variable, right? It is a function, so no error, but LED is not glowing. Check whether like you might have done some error. I'll just copy paste that code over here. Just cross check with the code. Uh, so like for whomever they are getting invalid header file, that means that they might have done. Whenever you use this wired library alone, even I faced this issue yesterday. So what happens is that if you might have done some syntax error, that syntax error won't be shown. Instead, that invalid header file will be shown. Okay. So the above thing is nothing. So now I have sent one code in chat that is for master. For master and wait. And now I have sent one code that's for slave. Just cross check with the code. I'll explain the code once again, but make sure you cross check the code I sent. So yes, master. So by this, I briefly explain this master. This master doesn't have many new functions. So wire.begin is one thing. So what does this wire.begin do? It initiates data transfer process from master, and wire.begin transmission that starts the transmission process by addressing a particular slave, and that slave's address is given as an argument. Okay, and that particular what value I must write onto the SDA line or data, I must give it as wire dot write off, and that particular value, in this code is nothing but the button state. Hence, I'm giving x is equal to digital read of button, and once I return that value, I must end the transmission. And this is in the loop. Once this end transmission is executed, that will end the loop, and then loop will start again. Like loop won't be ended. One time the loop would have run completely, and then the loop will again go to start. It'll go to wire dot begin transmission, and then the transmission will begin again. But this time, what thing will be passed is that like imagine I might press the button once. At that time, X might transfer one. If I don't end the transmission, one will be transmitted complete like continuously. Hence, I must make sure that transmission is ended, and as there is no delay here, the next command will go on immediately. And if I release the button, that will go to zero, and wire data will be X will be written onto SDA as zero only, and again transmission will be ended. So this is the more efficient way where we can run the circuit, and this is about master. So is there any doubts to this master? Cool. Is it clear? Yeah, adding NZ there resolves the invalid header file. That belongs to some coding related stuff. But like our main focus is on the electronics part. So circuiting and logic behind the functions of the code is alone more than sufficient to advance in this I2C communication process. LED is not glowing. Mm, just check with the code, check with the connections as well. Like, have you included resistor for the push button? Siddhartha, have you included resistor in the push button? Have you included very high resistance to the LED and all? Just check with that. Is there any doubts with master code? I'll explain the same code maybe once more. Okay, fine. No responses means clear, fine. I'll go to the slave code. So I'm including the wire library again. I've connected here LED to the seventh pin, hence I'm naming LED as 7. And I am initiating a new variable 0. Hence I have given int y equal to 0. What does this y do? This y actually reads the data from the SGA line. Okay. So wire dot begin of 1, I'm beginning the transmission or beginning the communication process in the slave which has an address 1. That is why wire dot begin of 1. I'm beginning the communication I2C communication process in the slave which is addressed 1. Okay, even I here it change. More than it is data transfer, it is the communication. Communication process from master here, and here it is the communication process from slave. And I have to put that address which I gave in the begin transmission in master. Okay. And pin mode of LED output, I'm setting the LED as output because I want this LED to glow. And for that, it must be set whether that is high or low, and then seventh pin must be output. Okay. And wire dot on receive, this on receive is a function which makes sure that receive event is set as a function to be used to receive the value. And in that receive event function, this there must be this int set. This mustn't be left void. And one more thing is that y is equal to wire dot read off. What will this y do? This y is the value which is being y is the value which is made to receive the value from the data line. Okay. And now if y equal to 1, then digital rate of LED pin here must be high or else it must be low. Is this clear? So is the slave code also clear? Wait. Can you explain why wire dot on? See that z is some value, like that is just a value used to resolve like uh, z is a value used to resolve that particular problem in your code. As of now, I can say only that. And can you explain wire dot on receive if possible? Hmm, okay. Yeah, as of now, I can say that it is an arbitrary attribute of the function. Y dot on receive. Okay. Y dot on receive is nothing but the function. It is just a method to set this receive event function as high, like not high. It is just a method to set that receive event function as the function which must be used to receive the value from the HDLA. And in that receive event, I must skip this wire dot read, like y is equal to wire dot read, so that y gets the value from the SDA. Is that clear? Copy pasted the code, but still header file missing error. Mm, Try for some spacing also. Yeah, like, yeah. As Adan said, we'll try to explain it here. Okay. Fine. Like we have come to the end of first part of the class. Like I mentioned those functions, right? These are these two are the functions which we have used in this whole process. Wire dot begin transmission, write and end transmission in master. And in slave we have used on receive, read and function inside on receive. That is the receive event function. Okay. Now you guys can take a break. We'll resume the class shortly after the break as time has been exceeded for the first thing and there are interesting stuff to cover. Stay tuned for the meet and then, yeah, my co-host will continue the class after the break. The value of register can be anything that might affect just the brightness of that LED, not necessarily the glowing of LED. So if you want to check glowing of LED, then just go on with whatever register value you get default. But 330 is very good value. Like you can get nice brightness with it. Wireless connection doesn't really need coding. No, I think wireless connections also needs coding. Wired and wireless both need coding. Coding is just setting up that for a particular type of communication. So even wireless needs coding. And yes, as in when are you planning to start this session after break? How many? Like how much?
Started for 5 minutes again.
Okay, fine. Break is just for 5 minutes, guys. Be ready for the next part of thing also. It's very interesting. And then about that on receive thing, I'll clarify soon.
Okay, so hi guys, welcome back. I know that you guys wish that the break was a little longer, but we have a lot of things to cover, so let's start right away. So yeah, in the second half of the session, we will be working on OLED display, OLED, or you can call it OLED, whichever works fine for it, works with you. So yeah, so as you can see, OLED stands for Organic Light Emitting Diode. Since it has tiny organic compounds which light up when current is passed through them. The major difference between OLED and LED LCD is that individual pixels can emit their own light in OLED, okay? So whereas in LED, we require backlighting to light up the entire screen, and then the light is selectively filtered to produce the desired color. So that's a major difference between OLED and LED. So yeah, before jumping into the programming part, let's see what we'll be using while programming. Okay, the modules and what all pins we'll be using. Fine. So let's first revisit the pinout for ASP32 dev kit. So as you can see, the default SCL and SDA pin are mentioned over here. The SCL pin is GPIO 22 and SDA pin is 21. So we will remember these pins while we will be making our connections. Okay. Okay. So let's look at the OLED module. This is the SST1306 module. As you can see, it has only four terminals: ground, VCC, SCL, and SDA. Since it uses I2C communication, the number of terminals required is just four. Fine. So before going on with the walkthrough portion, I'll explain how the memory is how the memory is used to display pictures on the screen. Okay. So the module has a 1 kilobyte RAM. This RAM is called the graphic display data RAM. This stores the bit pattern to be displayed on the screen. This 1 kilobyte memory area is divided into 8 pages from page 0 to 7. Okay, so these are individual pages, and each page has 128 segments or columns. So the columns are like this: 128 columns, and each column can store 8 bits of data. As you can see, each column has 8 bits of data. So, yeah, by calculating, we can see that 8 pages into 128 segments or columns into 8 bits of data will give you 8192 bits, which is equal to 1 kilobyte memory, which is the storage of the RAM. Okay, the RAM which is included in the this OLED module. Yeah, so let's see what we will be covering in the second half of the session. We'll be learning how to display text, shapes, and photos. Okay, so yeah, let's jump on to Walkme directly. Let's open a. Before jumping in, I'll I'll tell you what you can expect to learn and what you can expect to do by the end of this session. Okay, so like you can print these types of emojis or pictures on the screen. Yeah. So yeah, or you can also make complex games like this. Okay, we won't be exploring how to make games in this session due to time constraints, but yeah, you can make games also using this display, like this snake game which you might have played while you were young with your keypad phone. So yeah, like this is how it works. So let's go. Let's open Walktree first. Everyone, have you opened Walktree? Okay, so we'll be starting from scratch. Uh, let's open the ASP32 again. Yeah, so since I love ASP32 very much, so I'll be using ASP32. You can use other boards also, but you have to uh, take care of the SCL and SDA pins which you'll be connecting. Okay. But it is recommended to use ESP32 with me because in case of confusion, you can refer to the code uh, and the pinouts. Fine. So yeah, the first step is we have to include the library. So on top, you can see sketch.ino, diagram.json, and library manager. So go to the library manager and search SSD 1306. So you can see this Adafruit SSD 1306. So you have to click on it, it will get added. So you can, after it gets added, this will be visible over here in the install library portion. So yeah, we'll be using this library. So it is very important to include, install it. Okay. Yeah, sure, Satvik. I'll send it to you after the class. Okay. So after this is done, let's start with the connection portion. Okay. So I'll add this OLED display. Let's connect the ground to the ground and VCC to 3 volts, 3.3 volts. Okay. So the SCL pin, I think it was pin 22. So we'll connect it to pin 22, and SDA pin was pin 21. So you can do this with the following connections. So yes, we have connected SCL to 22 because the default SCL pin is 22 for ESP32 and 21 is the default SDA pin. We can change it using the in wire.begin. We can mention the SCL and SDA pin to change the default pins. Okay, but yeah, we'll keep using this only for now. First, we will include the two libraries which we'll be using. So include the first one is wire. Since we are using I2C communication, it is very important to use to include this library. Next, we'll include the newly added library, which is Adafruit underscore SSD 1 1306.h. Yeah, so we have added the two libraries. Next, we'll create an object file to this library. We'll call it OLED. You can call it anything you want. Doesn't matter because OLED is a little shorter. I'll call it OLED. So the values of the parameters or the arguments I'm putting, I'll explain it later to you. %, fire, -1. Do remember to put this semicolon. I do make this error of not putting a semicolon here. So yeah, let's come to the setup portion. Okay. Uh, so Siddharth, what is the error? What is the issue? Who mentioned the issue? We'll go on with the setup portion. So we'll write the begin function to initialize the object. So this will help us to start the connection with from ESP32 to the OLED display. So I'll explain what the 0xCC is also. Okay. Next, let's just write or display. So yeah, we are done with the setup portion. Okay. My bad. Right. Data proof. Yeah. 1306 SSD 1306. That it is SSD 1D. Okay, it's D. Okay, so try refreshing the page and selecting it again. Okay, I don't know why the error is coming for you, but I think it is working fine for everyone else, right? Okay, so yeah, I'll explain the code once. So this yeah, so we have included the YL library because we are using I2C communication. We have used this specific library for Adafruit underscore SSD one this SSD 1306 module. This will use we'll use this library to start communication as well as for displaying things on the screen. Okay, displaying various objects on the screen. We'll use this, and I'll explain the various like the various values we have used here. Like 128 is the screen width. Okay, so I might have forgotten to mention. Let's mention the coordinates. Okay, so in the column, the first part is 0, and the end last pixel is 127. And in rows, the first row is 0, and the last is 63. So total there are 128. The width of the screen is 128, and the height of the screen is 64. So yeah, the -1. You might ask why there is a -1 over here. So the -1 takes the we have written -1 because we don't have any reset pin. Okay. So this place we write the GPIO pin, which can be used to reset the screen. So since we are not using any, we can just write -1 to indicate that there is no reset pin for the OLED. Okay. So, but even if we don't include any reset pin, we can just use the ESP32 to reset the whole screen. Okay. To reset the whole program, it will reset the screen also. Fine. It is 0x3C. I'll explain what 0x3C is. Saket, fine. Yeah. So I'll explain the what this ampersand wire is. It might be a little complex to you, but don't worry, we won't go that much into it. Okay, that much detail into it. So in C++, ampersand symbol is used to denote a pointer, or it helps in giving the reference. Okay, this wire is an object whose reference is given by this ampersand symbol. Okay, to put simply the like we can't write any object directly in this place. This parameter can't take the value of any object, so we have to give the reference. So it is programmed in the library in that way. So we can't change that. Okay, so we can't write a wire directly; it will give an error. So we have to give the reference to the wire. So yeah, so the ampersand is used to give the reference. Okay. Okay. So, okay, Siddharth, I don't know why you are getting this error, but hmm. Just try, Siddharth. Okay. I will get. I'll give the program to you later. If you can try it, or just focus on the lecture. Okay, it's fine. So next is we have used this complex thing. This is a constant value from library. So it's I think its actual value is 2 or something. Okay, this actually states how power is it's a constant value from the library which actually denotes the power supply mode to the OLED. Okay, so the power supply mode is denoted by this constant value and 0x3C. So there is a question mark, right? Let's click on it and open what is so yeah, so the default value for this screen is 0x3C. So this is the address. Okay. So yeah, so this is an hexadecimal value which gives the address of our uh, SST1306 module in this I2C communication. So this is the default value which is mentioned in WOCP and which is we are going to be using. Okay, so this is the default value. So we'll make it remain as it is. So yeah, we have initialized the connection between ESP32 and we are going to display whatever is in the RAM onto the screen. Okay, like the as I said before, the RAM has 1 kilobyte memory, and it displays the bits in the RAM as if the bit for any particular position is 1, so it will make the screen get colored. Okay, like this is a black and white screen only. We can't expect color from it, but yeah, it will lighten that part of the screen. So yeah, since we haven't done anything, we shouldn't be expecting anything, right? We haven't written in code to add any text or any shape or anything. So the screen should be coming blank, right? So let's check if it's true or not. Okay, so we can see something like so this logo is coming, right? So I will explain why this logo is coming. So by default, when we initialize the connection, the Adafruit library puts this default logo on the RAM. So it's something by default which comes. We can remove this by using a function called. Okay, I'll use the function dot clear display. So yeah, this function will clear the screen. So so as you can see, while the program is running, now the screen is cleared. Nothing is being shown, right? So has everyone completed up to this part? I'll wait for you guys to complete it. If you do have any doubts, you can ask it. Okay. So guys, give a thumbs up if you completed up to this portion. Okay, nice, nice, nice. Sake, did you include the I said to include the library, right? Did you include this library? I don't think you will be facing this error if you included the library. Like in the project libraries, you have to install this library. Fine. Yeah, it's SSD. Yeah, nice one. Nice one, Bibu, pointing it out. Nice. So yeah, let's start displaying text on the screen. Okay, fine. So for displaying text, we have to first mention the attributes of the text. Okay. So after clear display, uh, set the set text size to 1. Okay, so 1 is the lowest available text size. Okay, so we'll set it to the lowest available text size. Then let dot set text color. Make sure that color doesn't have any hue. We'll set the color to white. So white is also a constant value. Okay, it is not a string over here. We have not used a string. It's a constant value. Yeah, then let's print the text we need to print. Okay. Okay, so before printing, we need to also set the text cursor. Okay, set cursor, cursor 20. You can set the cursor anywhere on the screen or also outside the screen, but you won't be able to see anything if you set the cursor outside the screen. Let's say I'm setting it at 20, 20. So next I'll print. Okay, so you can use two commands, either print or print ln. Okay, it works. Both of them works, but print ln, like in serial print ln, it prints and comes to the next line. Let's print something like hello world. Yeah, and semicolon. Make sure you added semicolon everywhere so that you don't find an error. So yeah, let's run this program and see what's the output. So yeah, it might take some time compiling sometimes, but don't worry. Yeah, so as you can see, hello world is printed. So is everyone done up to this point? Is anyone facing any error? Take your time, guys. It's fine. Take your time. Wiring, okay. Fine, fine. So like ground is connected to ground. VCC is connected to 3 volts, 3.3 volts. Like SCL is connected to 22 and SD is connected to 21. Fine. So I'll repeat again that 22 and 21 are the default SD and SCL pins, SCL and SDA pins. So yeah, we can change default pins like by using this function wire.begin, and in the parameter we can put the new pins which we'll be using. So yeah, since we'll be only looking at the screen, I have enlarged it. Hopefully everyone has done it up to this point. Yeah, so if you face any error, do mention in the chat. Fine, I'll tell you how to move the text around. Okay, let's move the text around. After displaying it, I'll write a function called start scroll. Let's scroll it towards the right. Okay, let's scroll the text towards the right of the screen. So inside we'll have to put two arguments. Okay, so earlier I discussed, right, every OLED display is divided into multiple pages, right? So it is like the OLED display is divided into 8 pages. So you can give, like if you give values from 0 to 7, it will scroll the entire page to the right. So yeah, start scroll right. Yeah, so set cursor is used to uh, uh, for setting the starting point from which the text should be visible. So yeah, this is what will happen. So let's say you don't want all the pages to move, only the uh, first, second, and third pages to move. Okay. So first page will be page 0, second page will be page 1, and uh, third page will be uh, second one. Okay. So 0, 1, 2. Let's make them move. Okay. So as you can see, only the first and second page moves. Fine, right? I hope your doubts are getting clear. Fine. So yeah, then yeah, I'll explain other commands like OLED dot start scroll. There is since there is right, there is also another function called OLED dot start scroll left. So we'll write another function called diagonal scroll. Okay, diag scroll. Right. Let's say left. Okay, we did the right other time. So write this function to start scrolling to diagonally to the left. Yeah. Let's see what the output will be. Like it's how the this like this function is defined in that way. Like the first value taken is like the first page. We can't scroll it bit by bit. The scrolling is done page by page. Okay. So I mentioned in the starting that the screen is divided into 8 pages. So yeah, so we can scroll page by page. So 0, 7 represents the whole screen. Okay. So like it has 8 pages in all, 0 to 7. So we are actually moving the whole page right now. So yeah, as you know that how you might have understood how to start scrolling. So let's learn how to stop this scrolling. Okay. Let's put a delay of let's say 3 or let's say 4 seconds. Okay. Now let's stop scroll. Scroll. So after 4 seconds, it stops scrolling. Fine. So yeah, this stop scrolling and start scrolling. This not only applies to text; it can be used for anything. Like in the further on, we will be learning how to display text and pictures. So we can also use this in that also. Fine. So is everyone done up to this portion? Do you have any problem? Want to mention in the chat box? Next, we will look into how to display shapes on the screen. Fine. So yeah, give thumbs up if you have done with you have done and completed up to this point. Okay, nice, nice, fine. Okay, so yeah, I'll start with how to draw shapes on the screen. Don't worry, you can. I'll provide you with the list of functions which you can use later on. So you can delete it right now. Means for now you can delete it. I will provide you the list later on. So yeah, for clear display, let's display a single point over the screen. Let's say we are gonna display a point. Draw. We have to use this line. Draw pixel, and the arguments we'll have to give is the x value and the y value of the position. Like the x value is the width value, and y value is let's say 64. Let's display it in the center of the screen and white. The color we have to give the color of the pixel. So this will display a pixel at the center of the screen. Okay. So yeah, as you can see, yeah, we can do it in loop, but just showing it is like, yeah, we can do it in loop, definitely. Next, let's draw a line. Okay, just replace this pixel by a line. So line requires 2 points, right? So we have to give the starting position of the first point, which is the x value and y value, and the ending position of the second point of the line. The x value of the second point of the line and y value of the second point of the line. So let's say our point starts from 10, 20, to, let's say, 120, 60. And one saw the 69. So yeah, as you can see, there's a pixelated line over here. So yeah, I'll quickly be going through other functions which you can use as time is limited, and we also have to cover the bitmap or displaying photos on the screen. So yeah, so let's say we have to draw a rectangle. So the rectangle's first point is the like the this is the it should be the x comma y value. The first argument should be the x comma y value of the first point of rectangle, and the next should be the length and the width and height of the rectangle. Let's say it is 60 and 30. Fine. So you can use these shapes to, like shapes are the basic things. You can use these shapes to print complex structures or something. Like even AutoCAD, you might have used. You, you can just build complex things from just simple lines. Okay. So yeah. Yeah, I'll tell you another thing. Instead of draw, if you use fill function, okay, like fill rect, okay, uh put this will print a solid rectangle on the screen. So yeah, if you switch draw and fill, it will switch from drawing a boundary to a solid rectangle. So yeah, so there are multiple other shapes which you can use. I'll mention them and I'll provide you. Okay, I'm looking at the error. Show the entire program. Nandini, you can show the entire program, which will help us to rectify it. Okay, so draw rect is yeah. So I'll explain the arguments which we'll give in draw rect. Right, draw rect is used to draw a rectangle, uh, boundary of a rectangle. Fine. The first is the x value, and second is the y value. So the x value is the starting point. This is the starting point. So like x comma y, this is the 10 comma 20 h pixel over here. Okay, the starting point is 10 comma 20, and it's the width is 60 and the height is 30, and the color is white. Okay, so we are printing on a white screen. So if we write black, nothing will be printed. Okay. Fine, right, Sangeeta? So yeah, I'll explain. I'll mention other shapes which you can use in your programs, and I'll give the uh, exact how to use those functions in the slides. Okay. So we can use round rect. So while the round rect will have curved edges, curved corners, sorry. So we can use fill round rect, we can use draw circle, we can use fill circle, we can use draw triangle, we can use fill triangle. So yeah, I'll use another interesting function over here, which is called invert display. So what if we want to convert this white portion into black and the rest of the black portion to white? We'll need to use this function called invert display. So invert display takes in a value, a boolean value. Okay, so we will give it true because we want to invert the display. Switch. There is a like OLED.begin SST 1306 underscore switch cap VCC. It should be switch. And then it should be switch. Okay, to mention to change it. Okay. So yeah, as you can see, the display has been inverted. So yeah, as I said, I'll be giving you the different shapes in the slides. Fine. The functions used to draw different shapes in the slides. Next, let's draw. Let's use the most. Let's learn the most important and most useful thing. Okay. So let's. So it's going to be the most fun part of today's session. Let's learn how to display pictures on the screen. Okay. So before displaying, we need to learn how to what we are going to display on the screen. So what we are going to display is called a bitmap. Okay. So bitmap is a image format which stores data of the color of every pixel in the form of array of bits. So we will need to create a array of bits of the picture which can be directly used to the display the picture on the OLED panel. So so we need to convert the whatever picture we have into this array byte. Okay. So the easiest method which I have found is through using this app, using this website called sorry, image to TPP. Yeah. So everyone open this GitHub page. So it will first, when we look at the interface, it will first ask you to select an image. Fine. You can choose whatever image you want. It could be anything. It could be even your photos. I use these photos. Okay. You can also choose multiple images at the same time. That is a great facility it offers. So yeah, I'll use the uh, okay. So I'll use the logo of Voltage Voyage. You can use any picture. Okay. It could even be your own picture. So yeah, after selecting the picture, we'll come to the image settings. Fine. In the image settings, we have to change the canvas size. So we are using a 128 into 64. Uh, like the width of the canvas is 128 and the height of the canvas should be 64. Like the canvas size refers to the size of the final image that should be produced. So next, so yeah, there is this thing called scaling. Okay, so this is very important. You have to keep it to scale to fit, keeping proportions. Fine. So you can change the background color to white or black. Like the picture I'm using, the background is black, so you can choose it accordingly. Fine. So I'll choose black, and I'll center the image horizontally. So the image gets centered horizontally, and this brightness alpha threshold. So you can play with it. You can change the value to get your desired output. So I'm going to, okay. Okay, so preview is like, did you set the scaling to this scale to fit Satwik? And did you set the size correctly? So if you do that, I don't think there should be any problem if you hit that. Like, what was the original size of your picture in pixels, file resolution? Like mine was like this much. Yeah, you can upload any type. Okay, any type of anything works. Okay, you can use JPG file. Yeah, yeah. Try using a different file. Next, I'll show you how to get the output from it. Okay. So yeah, code output format should be Arduino code. This is very important. Then select the generate code option. Then you will see something like this. This is the array which will be using in our code. So yeah, this is really important part which you have to pay attention to. So you have to copy this whole thing. Okay, you have to copy this whole thing until up till this point. Okay, you have to copy this thing up to this point. Control C, and paste it at at the starting before the setup portion. Fine. And you can change this name to anything. Like this could be anything. Let's say XYZ. I don't know. I kept it XYZ. You can keep any name. So the constant, I'll explain the variable type of XYZ over here. Like it is a constant value, which means it is not, it will not change during the program. Like it's an unsigned value. So unsigned means it refers to 8 bits of data. So every value here represents eight bits of data. So yeah, that's why we have used unsigned over here, unsigned character. So progmem. So yeah, this is something we use when we need to store the variable in the flash memory. Like flash memory is where the programs are stored in, like in any microcontroller. So we will store this in flash memory. So flash memory is a permanent memory. So even if you remove the power source, the flash memory stays as it was. Okay. Yeah. So that's what program stands for. So yeah, we have to keep this name of the variable uh, in our memory. So yeah, so we'll use this function to draw bitmap OLED dot draw bitmap. So bitmaps contain value. The parameters, the arguments we have to give for this bitmap function include the firstly the starting point. Okay, so we have selected a 128 into 64 uh, bit array. So we'll give the starting point as 0. You also, if you have followed my steps, give the starting point as 0. Okay, then we will be required to, sorry, xyz. So then you are required to give the name of the variable which you have used. Okay. So the next part, you have to mention the uh, size of the bitmap, which is 128, 64. The size of the picture which you have converted to bitmap, and then in the end the color. So yeah, we'll make it white, so it gets displayed on the black background. Okay, so let's remove this invert display, and instead we give it display function again. So yeah, this is the code. If anyone has any doubt, you can ask me in the chat. Okay, I forgot to also include the clear display. So yeah, this is the code. You can run it. Fine. You'll be able to see this, see the image on the screen. Fine. So is anyone else facing any trouble? Is everyone able to see their image on the screen? So yeah, we can use this to create games and such. So I used a delay, like in the emoji one. While creating it, I used multiple images and put some delay in between. Okay, so yeah, so I displayed this, put a delay, displayed another image, put a delay. Yeah, so yeah, that's what I did. You can also loop it. It's fine. Okay, so this is the website. You can just search image to CPP. The first link will be the right link. Okay, so XYZ is like I put a random name for the variable. Sorry, it could be anything. Okay, like it could be anything. That's why I wrote XYZ. So which part do you want to see? Yeah, fine. Like sharing the code is not enough, so I'll share the link itself. You can also access that link from here. Okay, just select this question mark. Leon bro, can select the question mark, and you can see the link from below. That's the simulator examples. You can see the snake game over here. Okay. Yeah. when the data type is like don't need to worry much about it. It already comes with file you copy with from image to CPP folder, uh, image to CPP web page. It's fourth line. Okay, like it's like it comes directly with the code. You don't need to worry much about it. But yeah, like the constant part refers that this is a constant thing which doesn't change. The unsigned character. So unsigned character refers to that every like every individual what do you say element consists of two raised to power maximum. It can hold values of two raised to power. Okay, two raised to power 8. So here there is 0xFF. So in hexadecimal, F stands for like 16. Okay, so this value is like is equivalent to 255. Like actually value ranges from 0 to 255. Total 256 values can be entered in a 2 raised to power 8 bit. So yeah, some places 0xFF is written, right? So unsigned character refers to that only. Like it can take values from 0 to 255. If you convert this hexadecimal values into let's say decimal values, you can find the actual values of these. So using hexadecimal because it is a better way to represent 8-bit data. Yeah. Okay, so progmem. Um, like progmem is used to write data in the flash memory of the microcontroller. So every microcontroller has a flash memory or where the program is supposed to be written on. So a flash memory is something like even if you remove the battery from it or the power source from it, the memory stays intact. So yeah, so the we have assigned the storage space of this to the flash memory. Yeah, so that's what program is. We'll program it into the memory. Yeah. So basically, yeah. The animation and stuff will be a little complex. We need to import other libraries, and yeah. So yeah, we have to import other libraries for animation and stuff. Like in the same Snake library, they have used yeah. So this other other library also. Yeah, we can do that. Like uh, yeah, Satvik, we can do that, but we have assigned a constant value. But yeah, we can do that. But so we need libraries which will make it easier. Okay, like we'll import libraries for that, and we can freely, libraries make our tasks easier basically. So libraries are made by the community, so that's why we need a good community or well developed community. Okay, so yeah, we can also print multiple pictures by giving delays. You can print a picture, remove that by clearing display, and then print another picture. We can do that. We can also put this part in the loop portion and continue the loop if we have two or more pictures. Yeah, so you can do a lot of things with it. So yeah, that's it for today's session. Actually, I'll give you the various functions which we have used. So yeah, the attendance form will be made available in WhatsApp. So yeah, make sure to fill the attendance sheet. So if you do have any else other doubts, you can ask me personally, or yeah, you can stay back and ask them in the chat box. For rest of you, the session is officially over. You can leave. Thanks a lot. Thanks a lot for attending. We will be providing the attendance sheet. Making okay, so like yeah, so the countdown assignment is so the submission for the link is available in the WhatsApp group only. The same link we can just change the session and submit it. Just there are option to submit two links. Just the first one is compulsory. The second one is not compulsory. So you can just add the first link and submit it like the JP. So yeah, so the image to CPP file is helps us to convert. Okay, let's say let's say I'm choosing this. Okay, so the resolution is this much. Okay, the initially the file resolution is this much. So yeah, we can adjust the canvas size. So this will convert the higher resolution into a smaller resolution. So everything is taken care by the this web page itself. So we don't have to worry about it. So this is the easiest way that I found on the net to convert any picture into a bit array, byte array. Okay. Thanks for attending. So do we have to select Arduino code? Just one. So yeah, I selected Arduino code. Uh, what it generates. I think it's similar only. But yeah, Arduino code is fine. Like it works. Arduino code works. Okay. So yeah, I don't. Yeah, there might be sites I don't know about it, but you can draw anything and yeah, you can draw anything and make them into this byte array format. The task will also be made available soon, just after the submission of the second task, and it will be made available. Don't worry about it. So yeah, if you don't have any other doubt, you can leave. Fine.
So, like, are there any more doubts? Or can we end the session? I think we can officially end the session.
I think it's fine. You can end it.